Hello class, and welcome to today's algebra lesson, which is all about functions. By the end of today's lesson, you will be able to determine if a relation is a function and evaluate functions written with function notation. So the first thing we need to discuss is what exactly is a function. A function is a specific relation where each input has one output. So in the last lesson, we were talking about relations, which were a list of ordered pairs. Now we're talking about a specific group of those ordered pairs where each x value, so each part of the domain, is paired up with an element in the output. So every time you put in an x value, you're going to get out a y value. One of the ways to determine if something is a function is called the vertical line test. The vertical line test says if a vertical line is intersected more than once, then the graph is not a function. So in order to use the vertical line test, you would draw a number of vertical lines. So I'm just going to go ahead and draw in vertical lines. And we're trying to decide if any of those are touched more than once. As we look through that blue curve, each black vertical line is only hit once, so this first graph would be a function. If I repeat this process with my vertical lines for the second graph, you'll notice on this last vertical line, it gets hit twice. So this is an example of what is not a function. On this third one, I want to point out that even though these 2 points line up above each other and it looks like it hits the line twice, one of the dots is filled in and one of them is open. Because one of them is open, it means it actually only hits once. So as I draw all of my other vertical lines in, this graph only hits each vertical line once. So it is indeed a function. So if it hits the vertical line twice, not a function. If it hits the vertical line once or 0 times, it is a function. So when we are looking at the graph, again, we can draw in those vertical lines. When it is graphed like this one is, and you have those those vertical lines going already on the graph, you can simply use the ones that are already penciled in as well. So each vertical line is only hit once. So yes, this is a function. And the reason that you would use is because it passes the vertical line test, which you can abbreviate to VLT. Go ahead and try this one on your own. This one is not a function because it does not pass the vertical line test. All of these lines in the middle of this oval are hit twice by the graph, so that means it is not a function. We can also identify functions based on the equations for these values or by the mapping or by the list of the domain and range. So if you are looking at an equation, the key thing here is all variables. So anything that is a letter within the equation must have an exponent of 1. So if I'm looking at this particular equation, I've got 4x equals y squared plus 8. Because there is an exponent other than 1, this is going to not be a function because of the exponent of 2. So because there is an exponent that is not 1, we no longer have a function. If you are given a table or just a list of ordered pairs or the map like we have here, our job is to decide if each input has one output. So I look and I say, okay, in this map, -2 goes to -3. It only has one output. 0 goes to 6. It only has one output. 3 goes to 6. It only has one output. 4 goes to 9. It only has one output. So this particular map does show a function because each input, so each element in the domain only has one output. So every time we put something in, we get a value out. It's okay that when I put in 0 and 3, they both have an answer of 6. What would not be okay if I put in 0 and the first time I got 6, and if there was a second arrow coming out of 0 that pointed to 9. So it's okay for two elements in the domain to go to the same range value. It is not okay for one element in the domain to go to two different range values. Go ahead and try these two on your own to determine if they are functions. The first one is a function because each x has an output of one y value. This second one in the table is not a function because x equals 1, or the domain value of 1 has the two different outputs. We can also identify functions from word problems or more in the context of problems. So in this particular case, 5 schools are competing in a long jump portion of a track meet. The distance of the players with the best jumps on the teams are as follows. Team 1, 20.6 feet. Team 2, 21.5 feet. Team 3, 20.9 feet. Team 4, 19.4 feet. And Team 5, 20.2 feet. So the first thing it asks us about is the domain and range. So when I am looking at the domain in this function, in this case, the inputs are the teams. What's determining the results are the teams. So I would list under my domain all of the teams that are competing in the competition. So in this case, it's Team 1, Team 2, Team 3, Team 4, and Team 5. Remembering, when we are listing domain and range, we want them to be in numerical order, which in this case it was to start. Then when we look at the range, again, I need to look at them in numerical order. So I want to start out with the smallest value, which is 19.4. The next biggest value is 20.2. Then we have 20.6, 20.9, and finally 21.5. So we list out those numbers for the y values, the results, in order. The last question it asks is this relation a function? In this case, the answer is yes, it is a function. And the reason being is that each element in the domain, so each input, has exactly one output. Every team only has one score that is reported within the competition. So because the input has exactly one output. Go ahead and try this one on your own, first listing the domain and range. So for our domain and range here, the domain is simply the people. If you put them in alphabetical order, great. If you put them in the order that they are listed in, that is also totally fine. Because it's not actually number values, the domain can be listed in any order. The range, however, needs to be listed in numerical order, and notice that 66, despite being the height of two people, is only listed once. Remember, if you are in the domain and range, you are only listing each element once. Now our question is this relation a function? The answer is yes. Every input, each individual person has their own height, even though one of the heights is repeated. So both in this case are functions. The next thing we're going to look at is something called function notation. This is a special way of writing out equations for functions. Normally, when I write out an equation, each variable represents its own piece. So y is equal to 3x says the inputs are the x's and the results are our y's. Function notation gives the function a name and tells you what variable you have. So it says function f with variable x is equal to 3x minus 8. What works nicely about function notation is I'm able to say pick function f and plug in the value of 1. So it tells you what function to use and what to plug in. So in this case, it would be asking me to do 3 times 1 minus 8. 3 times 1 minus 8 would give us, in function f, when I plug in 1, the answer would be negative 5. So for a couple more examples, this time it's saying f of x is equal to negative 4x plus 7. The first thing it asks me to find in function f is an input of 3. So it's asking me to do negative 4 times 3 plus 7, which gives me negative 12 plus 7. For a final answer, function f plugging in 3 has an answer of negative 5. When I come over to this next example, it is asking me to find function f, plugging in 2, and then add 1 to the answer at the end. So I've got function f, plugging in 2 means negative 4 times 2 plus 7, and then at the end of that, I want to add 1. So I'm going to do my multiplication first, which is going to give me negative 8 plus 7 plus 1. Then I'm going to finish solving the function part, which says negative 8 plus 7. So the function f with value 2 is negative 1, but adding 1 on at the end means that function f plugging in 2, adding 1 to the answer gives you a final answer of 0. Go ahead and try these two on your own. So we plug in negative 3, solve that to get negative 39. Plug in 4, adding 1 at the end, gives us 45 plus 1 for a final total of 46. Sometimes it's going to ask you to solve for two different function values, and then you'll combine those results at the end. If this is the case, you're going to want to solve each piece individually first. So I'm going to take function f and plug in 6 first, which is going to say 12 times 6 minus 3 gives us 72 minus 3. So function f plugging in 6 gives us an answer of 69. Then it asks us to also solve function f plugging in negative 4. So I get 12 times negative 4 minus 3, which is negative 48 minus 3. So function f plugging in negative 4 gives us a value of negative 51. Then the final piece it asked us for was function f plugging in 6 plus function f plugging in negative 4. So we can now take our two answers, which is 69 plus the answer to the second part was negative 51. So that means we want to do 69 minus 51, which gives us a final answer to the problem of 18. So if you have to solve multiple pieces, solve each individual piece first and then combine them at the end. Go ahead and try this one on your own. So first you do function f plugging in 10, then you're going to do function f plugging in 1. Finally, you are going to subtract those answers, getting you a final total of negative 44. Last thing we're going to do here is the same thing with function values, but in the context of a word problem. So Mason works in a movie theater after school. The function f of x equals 9.25x represents the amount of money he makes per hour before taxes. We're going to find and interpret f of 27.5. So the first part, we're going to find it, which says take function f and plug in 27.5. So I get 9.25 times 27.5, which is going to give me an answer of 254.375. Now the interpreting part means that we need to decide what the answer means within the context of this word problem. So in this case, it would mean that in 27.5 hours, Mason would earn, and then we have to look, because we're talking about money, we're going to have to round, so it's going to be $254.38. Go ahead and find and interpret f of 6 on your own. So we plug in 6 into our equation, which gives us 55.5. So our interpretation then would be that Mason earns $55.50 within 6 hours. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.